Hello everyone, welcome back. I'm Dr. Abhinay Inpamani from University of Florida, NFREC. In our previous session, we learned how to build a simple LED alert and how the circuits can represent the changing soil moisture using a potentiometer. Today, we will take the next big step, bringing intelligence to our circuit using the Arduino Uno. I welcome you all to the session 3, alerting the grower, blink and timing. By the end of the session, you will understand how to make a circuit think, read the data, decide, and respond automatically. Sounds interesting, right? So, we will learn about two interesting components today: soil moisture sensor and the Arduino Uno. Let's explore about Arduino Uno. Arduino Uno is a microcontroller board, basically a small programmable computer on a single chip that can sense the inputs and control the outputs. It's built around with the Atmega controller, which acts as the brain of the board. The board contains everything needed to get started, with electronics and coding, a power supply, input and output pins, and USB interface for programming. Let's look at the major parts of the Arduino Uno. The first one is the power supply section. The board can be powered either by a computer USB or an external adapter, 7 to 12 volts. It automatically regulates the voltage down to 5 volt and 3.3 volt in order to safely power the sensors, LEDs, and other components. Digital pins. We have the digital input or output pins from the 0 to 13. These pins act as either the inputs or the outputs. You can connect the devices like LEDs, buzzers, or relays to send the digital signals. If it is high, the value is 5 volt, and if it is low, the value is 0 volt because it's a digital pin. Analog pins. Analog pins are going to start from the A0 to A5. These pins read the variable voltage signals from the analog sensors like potentiometers or soil moisture probes or any temperature sensors. Microcontroller Atmega 328P is the tiny black chip that's a brain that runs your program. It reads the inputs, performs the logic, and controls the outputs in real time. You have a USB connector in order to upload the code from your computer and supply 5 volt power while testing. We have the reset button here, which restarts the program without unplugging the power. It's helpful for debugging. When you combine all these features, this Arduino Uno becomes a bridge between the hardware and the software. It lets us to write simple code that interacts directly with the physical components. The next important component is the soil moisture sensor. Soil moisture sensor has three important pins: VCC, ground, and signal. This change in voltage happens because of the resistive principle in the soil moisture sensor. You can see the sensor has two metallic strips called probes. These probes are going to act like electrodes that go into the soil. It works on resistive principle, as I mentioned already. So what does it mean? It means that it measures how easily the electricity can pass through the soil between the two different probes. So when the soil is wet, it contains water and dissolved minerals that helps the electricity flow easily. So the resistance is low and the sensor output a high voltage value. With this basic knowledge, let's try to go to Tinkercad and design a circuit. Go to your browser and type tinkercad.com. Click Sign Up. Create a personal account and then try to sign in with Google. I'll pause for a minute so that you can do it along with me. Once it is done, you can click Create Circuits. Now it's time to bring all the required components onto your workspace. The first important component is the Arduino. You can see the power pins, analog inputs, digital inputs, reset button available in the Arduino Uno. The next important component is the soil moisture sensor. Soil moisture sensor has VCC, ground and signal. It also has the two metallic probes. Next, we would be in need of an LED. LED stands for light emitting diode. Try to bring the resistor as well. Now it's time to give the connections. Connect the VCC of the soil moisture sensor to 5 volt of Arduino board. The ground of the soil moisture sensor should be connected to the ground of Arduino. Next comes the signal pin. We have A0 to A5 as the various analog inputs of the soil of the Arduino board. You can connect the signal pin to either of these pins. I'm just connecting it to A1. You can connect to either of the pins. With this, the analog inputs are done. Now it's time to look into the digital inputs. The digital PWM 0 to 13 can act either as an input or as an output. We know that light emitting diode LED is an output device. So we are going to use from 0 to 13 any of the pins. You can use any of these pins and connect them with the LED. Anode is connected to one end of the resistor and the other end of the resistor is connected to 13th pin. As I mentioned, this pin can act like input or output. It depends on how you are configuring that pin. The cathode is connected to ground. With this, the connections are done. How the circuit works. The sensor is going to check the soil moisture and send a signal to the Arduino. The Arduino reads the signal on the pin A1. If the moisture level is low, the Arduino turns the LED on through the pin 13, alerting the grower that water is needed. If the soil is moist, the LED stays off. This small system, it acts like a digital soil guardian, always watching and responding automatically. Now, let's move to the coding part. Why do you want coding when the connections are already done? So far, we built the circuits that work when we move the wires or turn the knobs just like a potentiometer. But what if we want our system to make decision on its own? That's where the coding comes in. Coding is how we communicate with the Arduino. It's the language that tells the board what to sense, when to act, and how to respond. Without code, the Arduino is just a piece of hardware like a body without a brain. With the code, it becomes smart, it can read the signals, compare the values, control any devices like motors or pumps, LEDs automatically. That's interesting. So, coding is what turns a simple circuit into a smart system. Think of coding as writing instructions for a robot helper. The robot doesn't understand our spoken language. It only follows what we write in code. Every line of code is like giving it a new ability to see, to think, to act. So coding becomes a part of our day-to-day life. So let's start to code today. We have an option called Code in the Tinkercad. You can click that. We have three different edit modes available: blocks, blocks plus text, and text. Click text. Then click continue. When you bring Arduino Uno to your workspace, this inbuilt code comes automatically. Although Arduino Uno can understand with the two different functions, void setup and void loop. Void setup is where you configure the pins as input and output. You need to tell the Arduino board which pins are input and which pins are output. Void loop is a function which runs forever. So let's try the code now. Imagine coding is like we are going to give instructions to the Arduino Uno. So the first instruction, I'm going to assign some name, okay, for all this moisture sensor what you're using. So let me give a name, int sensor pin to A1, int sensor value to 0. What does this mean? Int. Int is going to tell the Arduino we are creating a variable that stores a whole number. Sensor pin and sensor values are the name that the variable. We can name anything we like. A1 is the pin on the Arduino board. Sensor pin tells the Arduino which pin the soil moisture sensor is connected to. So here you can see I have used A1. If you are going to use A0 pin, you need to change it to A0 accordingly. Sensor value will store the number that Arduino reads from the soil moisture sensor later. So you need to think of variables like a labeled box, okay? It's like a label box which holds the information. So one box is going to hold the pin number and the other holds the sensor reading. Think of variables like a box. So it's easy to correlate. Next, it's time for void setup. So inside the setup, we are going to configure the pins as input and output. So in order to do that, we have a syntax pin mode. Pin mode 13, output. This setup function, it runs only once when we start the Arduino. Inside it, you have something called pin mode 13, output. This means that we are going to use pin 13 to send a signal. So this is where our LED is connected, right? So you're going to tell the Arduino that 13th pin I have connected an LED and that is an output device. Serial.begin 9600. This is like setting a baud rate, like how many bits you are transmitting per second. So this will help us to start the serial monitor, a tool that lets us to see the live readings from the sensor on the computer screen. So the setup part is like preparing the system before the experiment begins. Next comes the void loop. Inside the void loop, we are going to assign the sensor value equal to analog read sensor pin. So what this particular line does is, it's going to read the voltage from the sensor and then store it. Let's take the number 0. 0 means 0 volt. When I say 1023, that represents 5 volt, means it is a very dry soil. So a sensor value equal to analog read sensor pin will help us to read the voltage from the sensor and then store it inside a variable called sensor value. If you want to visualize the sensor value, you can use serial println option in order to see the value. So serial.println, what it does is it's going to print this value onto your screen. So you can see what is that value is. Delay 200. Look at the beauty of Arduino Uno. Delay 200 represents 200 millisecond, which is very, very small. That's how the Arduino board works. That's the beauty of microcontroller boards. Everything is in terms of milliseconds. So we are giving a millisecond delay here, and then we are going to look into the next command. The next command is if the sensor value is less than or equal to 500, then digital write 13 comma high, else digital write 13 comma low. The if-else statement decide what's going to happen next. So you have read the sensor value, and now what you're going to do next is we are going to check the sensor value. If the sensor value is less than or equal to 500, it means that it is a dry soil. So I need to turn on my LED. This is going to represent the dry soil. So turn on my LED. As a human being, when I say turn on my LED, you will be able to understand. But Arduino board works only with coding. So you need to give a command called digital write. So digital write is help us to visualize that as the output, and high means turn on. So digital write 13 comma high. What this command does is it turns on the LED. So LED will be on. If the sensor value is more than 500, give digital write 13 comma low. Digital write 13 comma low represents LED turn off. So in short, this code, it lets the Arduino sense, decide, and respond automatically, just like the smart irrigation system. So let's assume you have a value 300. So 300 is less than or equal to 500. When this condition is being checked, yes, 300 is less than 500, right? So the answer is yes. It means that LED will turn on. So this is how the if-else statement will work. And once you are done with coding, it's time to give start simulation. You can change the values of LED and see the output. There is a serial monitor option here, which you can utilize to see the analog value being converted into digital one. Try adjusting the value of the soil moisture sensor, and you can witness that particular analog value being represented in the serial monitor. In the coding, you have mentioned that if the sensor value is less than or equal to 500, I need to turn on my LED. So you can see the value is 35, and that's the reason my LED is on. And when will the value go to low? If the value is going to be more than 500. So now let's make the value to 863, and you can see that the LED is off. So this is the beauty of coding. Soil moisture content is the amount of water which is being stored in the soil. So it's usually measured in terms of a percentage. And you can see that the soil moisture plays a crucial role in the plant growth, nutrition movement, and irrigation scheduling. So when the soil moisture level drops too low, the plants experience a water stress. When it is too high, even that's a problem. So sensors like this helps the farmers monitor the soil levels can be monitored accurately, allowing the smart irrigation systems to water only when needed. Try giving the alternate values of the soil moisture sensor and visualize how the LEDs work. So in this session, you learned how to connect and program on Arduino Uno, simulate the soil moisture changes, and understand how the soil moisture sensors bring the real data into action. In the next session, we will add manual controls and explore how the data from the sensors can be displayed live for the farmers to monitor. Happy learning! And remember, every smart idea starts with a simple circuit.